Right. All right. So a story of blackout in 5 acts. Act number 1: loss and grief. Meet Jimmy. Jimmy, as a senior software developer, he became senior software developer ever since he read this book. Now, life for Jimmy is just awesome, right? They just can copy paste everything, pay them money, and all works. Until one day, this weird thing happens. Boom! And not only Stack Overflow, Google as well. And Jimmy is confused. Now, modern psychology tells us there are 5 steps to deal with loss and grief. So the first one is denial. Like, this never happened, doesn't happen, it's going to be 5 hours. The next one is anger. How can they do that? Like, isn't this software full current? The next one will be bargaining, like, maybe if I save actually some answers in my local drive. Next one would be just, depression. I will never be software developer ever again. And the last one is acceptance. All right, it's already Monday, 3 p.m. I'll try to do something. And we're entering this world where Jimmy has to do something. So, act number 2, the mess. Jimmy is about to create a new product for a customer, which is an auction-based software. It's like eBay. The only difference is we have 2016, so the name has to end with E5 and be in the domain IO. That's the only difference, right? Now, I've never worked for any auction system, so that we're gonna have some domain here. I don't know if that's correct, so if anybody here is from eBay, don't kill me. I just have to think of an example and came up with this. So imagine that we have an order in our auction system, and we actually can have 3 types of order. General order with list of products, a complex one, which is combined 2 or more orders together, and cancel, which means that there used to be an order but no longer exists. And a product can also be a basic one, which has an ID and a price. It can be a discounted product, which basically wraps over original product and gives a discount. And the one would be out of stock, which means that there used to be a product but no longer exists in our stock. So this is our domain from which we're going to start. All right. And those are features that Jimmy has to implement this week. So he starts with the first one, which is calculate the final checkout. All right. So before we start, we're going to create our domain object, which is in Scala code. It basically represents the same thing we saw a moment ago using images. So we have an order and 3 types of orders, and we have a product and 3 types of those products as well. So, with discount and complex has a list of orders and stuff like that. So Jimmy is using TDD, so he first wrote a test that should evaluate order. So now he has some order 1, order 2, which is with discounted product. The second is cancel. He created a final order, which is a complex order of those 3. And he has a solution. If he calls the evaluate method, he's going to get some value at the very end. The test obviously fails, and now he has to write implementation. Now, you need to know a thing about Jimmy. He's a senior software developer, but he used to be a junior software developer. And when he was a junior, there was this one particular book he was constantly being beaten up with. It's not a very bad book, but if you tend to just beaten up with this book constantly, at some point, whenever given a problem, you cannot find any other solution. You have to always look through that book. So this is like Jimmy in that state. So he thinks of an idea how to actually, conquer that problem, this evaluate method, and he thinks of a subtype polymorphism. So the idea is simple. I will define, so that I have those domain objects, and I will just define the evaluate method, the trait evaluatable with the method evaluate, and my order will extend that trait. So now every order has to implement this method, evaluate. That's basically it. That's what subtype polymorphism is. Now, the stuff that you're going to see in gray for the rest of this presentation is basically for completeness. It's just this business logic here. It's not really important, so I put it so we have everything that we can compile, right? But we don't focus really on the gray stuff. So now you can see that cancel is just been evaluated with the value 0. Complex will fold left over the element starting with 0, which is add up, and the general, well, it has to fold left over products and takes the value of product, which also has method evaluate. Why? Because product also implements that trait evaluatable and also need to provide method evaluate with those different implementations. This one, and that. Now, tests are working. Everything is green. And, Jimmy is getting, positive feedback. Wow, maybe I can survive. Maybe, it's going to be great. Maybe I've never needed Stack Overflow. So yeah, this feature is done. Awesome. So we take another one. Calculate average order price. So this is our test. So run on time some order, first one, second one, and third one. We create a list of those orders. We call the method average, and we expect some result. Now you have to remember, Google is not working. Stack Overflow is not working. How average is working? You guys know, Jimmy actually has to open his notebook from high school, but he thinks he's ready to implement it, right? It's gonna the implementation is gonna be simple. It's gonna reduce those values, divide by size, and this is that he creates this little library here for himself that will create the average value. And later on, he creates this final average method that will. So what he's doing is taking the list of orders, calling evaluate on that list. So now he has the list of those values, and at the very end, calls the mean method to get the average. Now he's almost ready to commit to repository, but he made a mistake. He actually bragged about this library here. And if Stack Overflow isn't working and Google isn't working, the rumor that the writing libraries will spread pretty fast over the office. So meet Jack, and Jack is like, oh, awesome! You're doing this library, I actually need it as well. Cool. But could you just make it work for integers and doubles? And so Jim's like, yeah, awesome. So what can we do about it? Well, it would be really cool if in Scala we just had a trait, we would get a number, and every other number, big decimal, double, integer, whatever, would inherit from it. That would just work, right? The problem is, no such thing exists. So, as I said, there's this book. Whenever there's a problem, you'll find a solution in the book. Not a statement here. I will never be hired in functional programming problems. The poor ever again. I'm kidding. All right. So Jimmy thinks of an adapter pattern. So the idea is simple. You're gonna create a trait number with some methods that he needs for his library, and he will have an adapter, basically a wrapper, that will wrap over his big decimal and provide implementation for those methods. And same thing would go for integer, and same thing would go for double. So now the difference that he will have here is that instead of having a sequence of big decimals, he will have sequence of those numbers of whatever they are parameterized with some a, and that number here, the number here knows actually has that method like plus and divide and so on. So that method, that thing over here, will no longer compile because it doesn't work on big decimals. It works on the wrapper, on the number wrapper, right? On the adapter. So we have to take our value, wrap it over the big decimal adapter, and as we see the value that we're going to have is the unwrapped value, so the final result we have to unwrap one more time. So, you know, there's a lot of products like here happening, just to, you guys probably see it, but I want to point that out. The tests are green, but Jimmy is no longer happy. Because he gets this notion what's going on. Like here, it's still not that bad, right? There's a little bit of boilerplate, but he can imagine any more complex calculation done using this adapter pattern, and he knows he's screwed. So like even though tests pass, Jimmy's like, but he continues with his work because it's already Wednesday. So that feature is done. Now the next one is to represent the current state of orders in JSON. All right. So what Jimmy will do, he will create one more time a new test, which will, he will initialize some order, next order, create a complex map based on those two. He will call on that final order JSON serializer write, which will provide him a JSON, and he anticipates to have that result. Of course, test fails at the very beginning. So now Jimmy is ready to write this method. And this should be plain easy. Just put the string right here to take the order, whatever type of order is, pattern matching, provide a result. But as I said, if Stack Overflow has been working and you write libraries, the rumor is going to spread through the office. So meet Kate. And Kate is like, hey, I'm already doing this library to serialize JSON. Could it work so, be more generic and work for every type? And Jimmy is like, okay. So, instead of taking orders and providing a serialized JSON, what it will do, it will take, something and provide that JSON. So, again, thinking of terms of that one book, he thinks of a trait he calls JSON serializable. So the idea is that it's going to be a JSON serializable trait with method to JSON, one more time, subtype polymorphism, and whatever implements that trait, we will be able to call that method right with it as an argument to that method. So at the very end, we will just write that thing to the final string. So we need those two, this JSON value and that writer that take that JSON value and produce the final string. So this JSON value is basically a trait with some objects. I'm not going to go into details, you probably know how JSON works. Also the implementation for it, as I said, is in gray, and it isn't that important, just basically it works, right? Produce a valid JSON as a valid string. But we don't really care how it works internally. What we care about is now, whenever we want to write some object to JSON, what we have to do is extend that JSON serializable, provide a method to JSON, and everything will work just wonders. So that's what we do. We add that evaluatable trait. Now we add yet another trait, JSON serializable. So we had this general order. Not only now he has a evaluatable method, but also that has to JSON method, which will provide a JSON value, and as I said, implementation is great. So that the same thing continues to every other class in that system. So for cancel orders, there's a JSON string. For complex orders, there's a JSON object. For products, JSON object, and so on. And the tests are passing. Cool. But Jimmy is not happy. Why Jimmy is not happy? Because he knows, he predicts what will happen. He once saw this comic. A life of a software engineer, clean slate, solid foundation. This time I will build the thing right way. Much later. Oh my God, I'm not gonna happen. And Jimmy knows he's going that direction. Because if we think about it for just a second, why method evaluate, which is closely business-related method, sticks in the same space as method to JSON? Right? Those are two different abstractions. Furthermore, Jimmy knows that evaluate means different things for different departments for the customer. Because evaluate might be evaluate order the amount of money you have to pay. But for example, for the department that deals with lost items, evaluate might be dealing with the order that was lost. So if you have to implement that functionality, what he will call it? Evaluate to, or something. He knows slowly building this thingy here, and he's not happy. Jimmy always thought his goal were, right principles, separation of concepts, epic decoupling, right? And he looks at the implementation and already knows that Frankenstein, right? So he thought, all right, before I provide any new features, I will try to think of a better way to do it. And so comes the act number 3, reinventing the wheel. So he starts with the thing he thinks is the easiest one, the problem with that adapter thing. You remember he had to provide a straight number and different wrappers for different types that would provide the implementation plus and divide and so on. And that was the usage of that. So he doesn't like it. He thinks it's crappy. What Jimmy wants is this. This was the initial thing that he had before he had to be more generic, right? Take into consideration different types than just the decimal. Now, but he has to deal with different types. So his method here is basically taking A, whatever that A is. And this thing will not compile, right? Because we don't know what A is. We don't know if it has a plus method or divide or whatever. So Jimmy's thinking, okay, I don't know if I can divide or sum that type. So maybe I can provide somebody here that will know it. So he creates a trait called number that is parameterized by the same type A, and what that number does, the only thing that it do is just knows how to sum and divide things of a type A, whatever that A is, big decimal, string, integer, whatever. So he will just use those methods here: number, divide, reduce, number plus, and size, and it works. So now he had that trait defined over here with those methods. It looks pretty, an implementation for big decimal, an implementation for integer. It looks pretty similar to adapter pattern. The only difference is we're no longer wrapping around anything else. So we used to have this wrapper here, and the plus method took one parameter. Here we are just taking two parameters and tell what that function should do with those parameters for integers and for big decimals. So it's basically an instance of that trait. So now, in order for this code to work, as you guys remember, this works on big decimals. The only thing that we have to do is provide that second argument, that big decimal number here, and we'll just know, right, how to divide and sum things of a type big decimal. However, because this is Scala and we define stuff with okay, how many of you guys don't know how Scala works? Okay, I thought it's going to be like this. So the only thing is that if you provide this implicit keyword over here up front, it will. And your argument and your function is also starting with the word implicit, you might provide it explicitly, like we did over here, and this will compile. But you might forget about this parameter, just don't pass it around. And normally this code wouldn't compile. The compiler would say, like, listen, guy, you have two arguments here, you just gave me one. But if he sees that the second parameter is defined as implicit, so he will look for implicit definitions in the scope. And we've imported everything that was everything that is defined in that object is defined with the word implicit, right? So if we import every object from this number object, it's going to be available in the implicit scope. So this will just magically work. Okay? So now Jimmy has this solution, like this is this eating an egg and having it too. He has very generic implementation of this mean method while we're using it from the user perspective of that method, it looks pretty much as that method was created just for big decimals, right? And the only difference is it has to import this magic number and whatever it holds underneath. The only thing that is not really nice is that previously he had just like, reduce plus and divide. It was more mathematical approach. Now we are calling some methods. There's another thing in Scala. So the thing that we saw over here was called implicit arguments. There's another construct in Scala which is called implicit conversion, which basically means that you can provide, this is sort of like a wrapper class, right? It takes as an argument something of type A and wraps over it. But just see one thing, we one more time provide this definition with this implicit keyword up front. And what it will do, well, if we put this code like here, we have something of type A, right? And we are saying A plus A. Before compiler freaks out, he will say, okay, I don't know anything about A. I don't know if A has a plus, but I will look for a wrapper class that takes an A as a parameter and is in implicit scope. Do we have such a class? Yes, we have a class that takes an A as a parameter and is implicit scope. So what it will do internally, it will wrap our A's into the instance of that class, right? Internally as a compiled version of it. And as you can see, all those plus method operators, plus and divide are implemented here. So it's a little bit of magic this way, but we get this notion as those operators were defined on type A, plus operator and divide operator. So far so good, especially for guys who are not comfortable with Scala. Is that comprehensive? Sure. Can you guys understand? Sorry. It's my second talk today, and as I said, English isn't my native language. All right, so now it just all looks wondrous. It's just having a code and getting it to do it. We have it. It works. Great. Tests are passing, and Jimmy's happy, and he thinks now, damn, I can do it with everything here. So the next thing was this, JSON thing. As you guys remember, we had this subtype polymorphism. We had to implement that to JSON method. And then you could serialize it. So, and we have to provide that method to every class that extend that trait. So what we will do, we will just completely remove it, right? And we will say that this JSON serializer will actually, instead of taking something of type JSON serializable, will take anything of type A, whatever. It's going to be a very generic method, okay? And we will be able to serialize it to a JSON value. But we don't know how to serialize it, right? We have the exactly same thing. It's like a parallel code this way. Because right now we will just provide a guy, which we call JSON, who will know how to serialize that thing of type A, whatever that type A is. String, user, char, whatever type you have. So we have to provide that trait, right, with this method to JSON, and we'll create those JSON values. One more time, we have to provide instances of this trait, right? So we're going to provide an instance for a product, and we're going to provide an instance of that trait for an order. One more time, I'm giving you the implementation, but this is just basically, details of the business logic. But the most important part is that we define a trait that it will know how serialize, take any type, A, and turn it into a JSON value object. And we provide instances of that type for two other types, order and product. So now, if we remember how we had this code over here, that works on any type, of any type A, as long as we provide an instance of that trait. So in tests, if we only provide those instances for order, this test will work. All green. So now Jim's like, yeah, I can do it. Till the very end. Last thing is evaluatable. And he's going to do the exactly same thing. So, you know, we had an evaluate method that was in all those objects. So what we're gonna do is we're gonna create a trait, evaluate, which basically what that trait tells us is if I have an instance of that evaluate trait, I can, when call a method of type A, I will produce value of type T. So I can take whatever A and produce a T value of it. And one more time, we are providing instances of that trait, the implementation of what that means. Basically copy-pasting that previous methods that were close to the domain objects, but they're just now living in one space. So guys, remember we have this average method, right? And we were calling on every order method evaluate. But this method was deleted from our domain object, right? It no longer exists. It will not compile. So we have to make one more time this trick, this evaluate ops, this wrapper. Whenever you are looking at something of type A and the user wants to call on that type A method evaluate, wrap that thing over me and I will provide that method. So now we can call it as if that method actually existed on our order. This implicit magic will just wrap our order into evaluatable ops, taking that order as a parameter and giving us this additional method that we need. And yay, Jimmy is happy because he's back to his original design. Right now, one more time, his domain objects are just simple classes that defines the domain structure that he developed talking with domain experts of that option system. Nothing else here. All the functionalities are added ad hoc whenever they are needed. So the difference that we have is that it used to be that every class in that system implemented every needed method, and those guys who are really into object-oriented design, they're going to be like, well, yeah, hey, if you're going to add right now a new, let's say, class of type order, normally in object-oriented design, all you have to do was simply implement all those methods in one single class and it will work, right? That's true. But if you had to add a new functionality to your system, you'd have to go through every class in your system, whatever implements the given interface, and add that method. And now the question is, what's changed more often in your system, functionality or structure? I would argue we have functionalities and structures that change less often than functionality. Act number 4, the Renaissance. So, Jimmy now understands how this thing works. You want to push that to the next level. He has the final method, the final functionality, which is called simplified orders. The general idea is that given the list of orders, you want to compact them together as a single order. That's basically it. Well, he thinks of like, this is basically like folding left over, right? So if I provide a 0 value, which I think like meant maybe cancelled order might be treated as 0 because every order added to cancelled order will be just that initial order. So all I need here is just this plus, right? The ability to add 2 orders together. If I could provide that functionality here, the whole simplified method that I need to work on here right now will just work. But he will no longer use subtype polymorphism. He will use what he just learned a moment ago. So he will one more time create. You see that I'm repeating myself, right? I'm just doing the same thing all over again. He creates a trait that will know how to add 2 things together and provide that new thing of the same type. He creates an instance of that trait for order there. So there's an implementation how to add 2 orders together. And given that addable, given that, he has to only now provide one more time this wrapper, so it would seem like this plus operator actually exists on any object of type A, and now this thing will compile. Given the import, we have to provide the implicit scope, this thing will compile. So one more time, it looks like if that class was already defined on the order object, but it isn't. It's defined somewhere else. There's a single file that says how to add two orders together. But we can use it as the class was existing on that type order. But as Jimmy sees that it's actually still a lot of boilerplate, right? Because the only thing that he needs here is the zero value and ability to add things together. The rest is boilerplate. One more time. Wouldn't it be just cool if there was a fold method that would know, like, I need a zero value and I need to know how to add two things together. So it thinks of an addable with zero, with two methods, the add method that we've seen before, and zero, which is a new method representing the zero value for fold. So that fold method over here, very generic method, will work on sequence of values of any type A. They're just saying this, listen, I will work with whatever you give me. Like, you can give me anything, right? You know, as long as you provide an instance of that trait. That's all I need. Give me the ability to add things together and a zero value, and I will do the rest for you. So we have that add method already implemented. We only need to implement the zero value. And the zero, as you guys remember, was just this cancel object. So given that addable with zero, the order with zero, we are using the method here, and this will just compile. And now Jimmy has this moment, the Neo moment, like a matrix. Yeah, I can do it everywhere. Because he looks at the stuff we already developed, and he sees places where it can, use it, where it can be reused, like he can use that generic fold method. As long as he creates addable with zero for Greek decimal, this is going to be just fold, right? So he has this Neo moment, but before he does anything else, the Stack Overflow is up and he'll do something. So now, the act number 5, the Enlightenment. Because Jimmy will do what he was supposed to be doing in university, research. And Jimmy learns that actually things he invented existed way before he was even born. So here will be the definitions. So so type classes, there are some languages like Pascal where type class is a built-in concept. It's a concept built in language. Scala doesn't have that concept. It has concepts like implicits on which the type classes are implemented. So whenever we saw that number, that JSON, that addable with zero, addable, those all were representatives of a type class. So what type class is? If you think of a type as being a subset of values, set of values, think of a type class as something that define a method for you, some set of functions for you, and if a given type wants to be a member of that type class, he needs to provide implementations for those methods, and that's it. So I have some type class defined with some methods, and if I have some type here over here, let's say user. Hey user, you wanna be part of my type class? All right, awesome. Here's your sign form, right? You have to apply for it. You have to implement those two methods. Once you've done it, you're a member of my type class. Awesome. So that's the thing. And what Jimmy was doing when he was removing subtype polymorphism, but he still had the notion of as if the subtype polymorphism was there, because he still could use those methods to JSON, class, and whatever, even though those were not defined on the order or the product. It's called polymorphism. Now the ability to provide domain objects in the way that he had them, but just plain objects. If he had research, you read about algebraic polyprocessing. Database. I'm sorry. I apologize. I will learn at some point. So now he can actually get those principles and things he wanted to have in his code quickly, easily. So now the funny part, all those weird words we've been hearing about, semigroups, monoids. A semigroup is this addable. That's the thing. That's not exactly it, because normally when you have a type class defines some functions. Those functions sometimes they come with the laws. The function, if you're going to implement that function, that's cool, but the function has to also obey some laws in order for it to work. And the laws for a semigroup would be that it has to be associativity. So A plus B plus C, so that if you're going to add A plus B and then add C, will mean exactly the same as adding A to B plus C, pushing those parentheses. You know math, right? Okay. A monoid is our addable with zero. It's just a freaky weird name. That's it. That would freak me out last year when I was here. Basically, that's it. And last year I was doing this talk about what a monad is, and I was trying to provide like a general idea of how I understood it. For me, right now, monad is basically a type class, nothing else. It defines some methods with some laws, and that's it. Now the question would be, why should I have a monad, right? Why? That's a completely different story. Why would I actually need a functor or applicative or a monad? That's something completely different, and probably a separate presentation for it. But what it is, it's a type class. If a type has to be a member of a monad, it has to implement the methods, and those methods has to obey some laws. Now I don't know how much time do we have, because I have some code for you if you're interested. I don't know, we have like 5 minutes, 10 minutes? What happened? Maybe don't. Okay. Alright, so if you guys want to leave for other presentations, go. I'll just show you something, because there's I've been playing around with. So last year I was when I was at LambdaConf, I've attended a few advanced talks where the guys were talking about Scala Z and cats and everything. I didn't understand any of it, and I thought like next year I'm gonna be here. I just have to understand what those guys are talking about. That's why I've started playing around with cats and Scala Z. I have like a little sandbox project where I just go through every type class in it and make it bigger, right? Try and understand what those are. So I'll just maybe quickly run through two and just whenever you play with type class, you first need to understand what it does, and then you have to think for a minute why would you ever need it. So in cats and in Scala Z, I'm going to say cats all the time, but you'll find equivalents in Scala Z as well. All right. So there's a method which is called like equal, but it's more like a JavaScript one. But the idea is, see if two objects are equal. It's exactly the same thing as if you do normally Scala equal sign. The only difference is that you have is that if you try to, if you try to do something like this in Scala, right? Try to see if integer is equal to string, this will compile. Awesome, right? The only problem is that it always will give you value false. You could just say println false. It will just mean the same thing. If you're gonna use that function equal sign, this thing will not compile. All right, and that's basically it. So the type class, if you want to have an instance of that type class created for you, the usage of the type class is only because it gives you this knowledge that if you will compile two things from a different types, it will just not compile. There's a type class which is called show, and show pretty much works like toString, right? This is the same thing. So you might wonder, why would I even need show if I can just call toString? Well, the thing is, if you don't provide toString method to your class, let's imagine that we have some class like here, foo, right?
If I don't provide toString implementation, it wouldn't be a case class. It would be like something like that. The value of a toString method would be like real, like some hash codey thingy, nothing readable to the user or nothing readable in logs. So show works this way. So if you call toString on an instance of that class, it will all compile. Now show extends your type, gives you this ability to call the method show on it, and if you don't provide instance of that type class for your type, it will not compile. So imagine you have a user, right? You didn't provide instance of a type class show, then when you're going to do new user.show, the code will not compile. The toString it will give you a crappy result. So you get this you get this ability to be more have more positive attitude towards your code that it actually will do what you hope it will be doing. All right, so I see people leaving. I will not go through those functors and stuff like that, but basically if anyone is interested, I will post the link to this repository where I basically go like type class by type class and try to, with code, explain what it does and stuff like that, if anyone is interested. Besides that, I like drinking beer, so if you have any questions, I can answer those in the evening. And thank you very much.